Right, I'm going to continue the work with my DAC. This is the 332 DAC, the manual encoding that I tried to get to work. The problem is this is 5 volts or 0 volts into the DAC. The DAC converts it to an analog signal for the VGA. Here for the VGA card, you can just see off the edge of the screen here. The problem is at the moment is we can only output the video, the color data, while display is on. This entire circuit here and this bit here works out the signals for video on. Most of this is actually to generate the horizontal sync, vertical sync at the correct resolution. As I said, this DAC creates the 0 to 0.7 volts needed to generate the color, the correct colors we require. Unfortunately, the error I made last time is I take the output from this, take it into a 7.4 series TTL logic gates, and it with the video on before outputting it. Obviously, the TTL logic gates only work on effectively on-off signals. They're a digital system, so we don't get the analog signal through to this, as it's negated by this series here. So what I'm going to do is I'm going to use a 7.4 HCT 541, a tri-state octal line buffer chip, to take the manual input, which will come from the RAM eventually, take the manual input into this, use this with the video on display to enable or disable the output through to the DAC, and then take this onto the VGA board. This is the idea. We'll need this chip, which I say is the 7.4 HCT 541, the octal line buffer, because it has a twin output enable, which will connect together. We only need one, but we do, however, as it's a active low and our current system is active high, I'm also going to need this chip here, if I can get it connecting, and this is just simply a hex inverter to invert the signal. Now with a lot of these systems we just need a small capacitor connected to the power line, between the power line and the ground, just to isolate any power spikes we might have. So connect that up there. I'll just take another one, bend it through and clip the legs. So we've got a similar one for this chip, again between the plus voltage and ground. Then what we just need to do is connect the actual plus voltage line. Do that for that one. For this I will use the correct wires and colour coding at a later date. Just quickly for today, I just want to test it, so I'm actually cheating and using a pre-purchased set which has various wires at various lengths. They're not ideal because they're never quite the right length, but to just do this test, this will be adequate. So this connects the, oops, this is again where we see the problem in that they're not quite the right length and they're really annoying, but it'll do. So we'll connect to the power up. I now need to get the negative. I've got the power until connected these two wires here, just temporarily, just to connect the power through. I need to do a similar again, just for the other side. I'll have to use some. Again, I haven't quite got the right cable lengths I need, but we just take the positive through to positive, and then negative through to negative. I really hate doing this, but I just want to test that this is the issue. Now we need to, I need to take the output from my, this where all the signals are compared, and this is the final output of videos, like the final video on that takes all the various other signals. I need to take this to pin 1 of my hex inverter, and then I can take that. Hopefully this is long enough, not quite long enough. Choose something a tiny bit longer. And again, this is quite horrible. So we've inverted the signal from the hex inverter. We'll take that to this pin, which is output enable 1. As I said, the HET 541 has a twin output enable. One's on pin 1 and one's on pin 19. We're going to use the same, as we don't need two different ones. So we'll just connect that up like that. We need to connect these. We've connected the positive. Ground is on pin 10 of the 541. So we'll just ground that as such. And we also need to do the ground on the hex inverter, which second place, but pin 7, as it's only a 14 pin dip rather than a 20 pin. So we'll ground that. So that's actually got the plus volts and the ground for the chips. We've done the hex invert, and we only need the one that comes into the output enable onto both sides of our own output enable. Now what we'll do is for our initial test, we need all the inputs for the line buffer are on this side of the chip, pins 2 to 9. So for my test, I'm going to connect them all to the initial test. I'm going to connect them all to the plus volts. So let's quickly move all these cables here and just quickly connect them all to plus voltage. So on my initial test again, which to be fair worked before, I say this will come from RAM. It will probably come via a buffer, such as a 574, something along those lines. Just because of RAM reads and timing and everything. We'll go into that in more detail at a later date, but for now, what I need, actually I'm going to use slight differences. I'm going to use the first 3 as the red. I'm going to use a different colour for the green. So we use the blue, these blues for the next 3, which are the green components. And then the blue only has 2 components. So I'll use, I'm just going to move this little ground wire here. I'm going to move it over a bit just to make life a bit easier in a minute. There we go. Now I've got all my pins easily accessible, so I can just drop them between +5 and ground to do all my various tests. So at the moment they're all going to be on +5. So I'll take this one as well. And connect that to the +5. So now I've got my 8 data bits, 3 red, 3 green, 2 blue. Going into my line buffer, we've got the output enable line from the video on, going via a hex inverter because it's a low power signal for the output enable. Now what we need to do is we no longer need these. This was the other mistake I made. I still have my 470 ohm resistors from my initial tests. What I can now do is I can actually disconnect these wires. These aren't actually needed anymore. I'll just tuck them out of the way for now. My blue output will go here. My green output will go here. And my red output will go here. This is from my DAC. So now all we need to do is connect. So I need several cables. The pin 2, which is the first bit of the red, needs to come from output here. Unfortunately, needs to go. Oh, probably need some longer cable than that. Needs to come from here all the way across to bit 0. And then we've got bit 1 of red to bit 1. Bit 2 of red to bit 2. Connect the same up for green, which has got 3 bits. So this is green bit 0. To output 0. To output. Let's say this is fairly messy how it's done here, as you can see, compared to the rest of the board, where I cut the wires nicely to the right length. If this works, I'll go back and tidy all this up. But just to have a quick test, as I haven't tried anything like this before, I'm just interested to see if it will work quickly. So we'll connect those, and then we just need a couple for the blue bits. So here's blue bit 0 onto blue bit 0, and blue bit 1 onto bit 1. So that is the video board. We've got the VGA signals creating the H-Sync, V-Sync signals as before. The various front porch, back porch, video on signals are all being checked, coming through here all together. Our final video on comes across here, hex inverted, due to the fact we need output enable being low. I've got a manual input of bits here going to my line buffer, and providing the display is on, these will then come here. If the line display isn't on, it will give a high impedance because it's 3-state output. This isn't a problem because once it comes through the video, the monitor side of the VGA is set to via a 75 ohm resistor, as explained when I was explained the DAC. It's got a 75 ohm resistor to ground, which means if there's no connection, either because there's no cable or in this case because we've got high impedance, it'll be grounded out to give 0 to give black. So we're fine, we don't need to pass the 0 volts through if display is off. We can quite happily, as far as I'm aware, we can quite happily use the high impedance 0. We'll find out soon if this works. So the next stage is to connect this all up to the monitor and see if it works. Right, I'm going to give the test, so I'm going to connect my monitor up like so. I'm going to move this slightly to, I have to spin this round so I can, there we go, spin this round so I can connect up my power. There we go. Now, as I say, this is got +5, we're on the positive for all the pins here, so the idea is, as I switch this on, you should get that white signal, or white screen, Let's connect it up and see what happens. I wouldn't say that's white, that gives a very interesting effect. Got no input on pin 1, which is interesting. Maybe that's just me connecting things wrong. Let's just check on this side. So we've got power, we've got one of the AND inputs, which this is one of the other AND inputs. So actually the input we wanted was this one. This could have been the problem. This is the, because we need to AND, vertical and horizontal is on. That's what we need. So let's take these out again and now reconnect. And put some here, so red. Ooh. We now have a red screen. Now we've connected that wire. We have the red screen. And if we connect our green wire, oop, not that green one, this green wire from over here, our DAC. That gives us another colour screen. It's not quite yellow, yellowish. Could just be our values we're checking. And then and our white. One of the things I've just realised is I've still left these 470 ohm resistors, which is why the colours might seem a little bit odd. So I'm going to take them out again. This is a problem when coming back to boards after a few months, since you forget exactly which pins are which. But if I now connect these on here, we get a much better colour output, as I'd be expecting. Let's put these cables that way. Now I've got a nice bright white colour screen. The next thing to try is to try altering our colours. So to start with, let's try taking the red and the green components to ground. So this is effectively using the 0 for the red and the blue, the red and the green. This just gives our blue component. So I wish I'd used longer cables. Probably a bit easier. But I'll just quickly test it. So taking these across should give us, as we expected, our pure blue. Now this is our one. We've got 2 bits. This is our 1-1 colour blue. This is our full blue. Now the next thing we want to try. So we've got bit 0, bit 1, both connect to 5. The next one is, which is 1 and 2, which is 3. So in binary, our next step down would be 2, which is connecting our 0 pin to ground. So now this should be a slightly, it is a different blue, but I may have got some resistor values are slightly wrong for what we need, as I've gone fairly linear. So this is 2. Let's just move back and forwards a bit. Might be slightly different. Let's now go down to 1. So we need to move this one onto 0 and this one onto 1. This should be a dark colour again. That does look a bit. Does appear to be a bit. Watching with the screen, My phone screen seems to be slightly different. I'll move on to video. I'll give a slightly better appearance. That's the one colour. And then obviously, as expected, if we move down to 0, we get no colour. If we try this experiment, the red has got a bit more variation. So let's start with going up to 1 on the red. So as expected, I'll try and hold my phone still so I can get some videos of both. This is the one colour of red. It's actually a solid screen, doesn't look like it so much on the phone screen. I'll put that back to 0. I'll now move the second pin two up. That's the second level. If I bring the nut to 3, there we go. I have to take them both out. I connect to 4, we get a bit brighter still. Oops, sorry, leave 4 in. Bring 5 in. Oops. I should knock out the extra cable. Let's connect that back up. So that's with 4, we had 5. Let's try with 6, it gets a bit brighter again. And with finally 7. There's not a huge difference between our. We might want to adjust our DAC a little. There is a you can probably just don't know if you see it on the screen. That's our 7. As I said, there's a very, very slight change. I'll have to probably investigate logarithmic scales for the colour. But that seems to be fairly good in that it is working. We're certainly getting different shades. We pick a value now, so we can go, let's say we use bit 4 of red, bit 2 of blue, bit 4 of green. You get a sort of a grey scale. I guess slight hues of pink. I suppose the test will be if we take off we just have nothing on blue, top bit on red and top bit on green, you should get like a yellow. And it's like yellowish, looks a bit greenish, but I think that's partly to do with the camera. It is more yellow what I'm looking at. If I now connect full red and full green, to the +5, that should be the brightest yellow we can get. And as I'm doing this, I can see that it's becoming more yellow. For some reason, I think it's because the light in this room still looks a bit yellow, a bit greenish on the screen, but hopefully you can see that is a yellow. It looks like a fairly bright yellow as you'd expect to me. So I might have to play around with my DAC slightly, just to vary the. I think we're going to have to look at logarithmic ranges. I'll have to do an investigation onto the logarithmic scales. I'll write some information as I find it, but as it stands, that is a DAC. It does allow us to vary our shades, as we'd expect. Would be nice. I'm almost tempted to look at doing a more of a. As I'm looking at doing 2 screen modes, an indexed colour and a. I was looking at doing an indexed colour and a true colour. This was the true colour 332 mode. The indexed colour, I could use more variations. I could work out a a 16-bit DAC. So 565, 5 red, 6 green, 5 blue. So a 16-bit DAC, because I could have a palette set aside. It would involve a secondary circuit. Wouldn't be that hard to do. Would give a lot more colour. Is tempting to do. It is tempting to do, having looked at that. Just because I'd like to see more colours. But it is quite nice to be able to play around as I am and get different colours on the screen. Sort of like a cyan colour there. So yeah, all in all, that seems to be quite a nice success. I'll leave it there for now, and I shall see you on the next video.